let's begin talking about circular motion. In order to begin talking about circular motion, we first need to understand what's happening when an object is going around a circle. So let's talk about a vertical circle. As it swings around a vertical circle, we always have the string that's pulling the object in towards the center. Therefore, circular force is always in towards the center. Because force is a vector and acceleration also is a vector, acceleration is also towards the center. Now, velocity around a circle speed around a circle may be constant, but velocity is not because it is constantly changing direction. So speed or velocity is always tangential to the circle. Now we know that in order to find the circumference of a circle, we have to find the radius and multiply it by 2 pi. This is important because this becomes our distance around the circle. Whenever we want to find velocity, velocity is always distance over time. So in a circle, it does have time, but the time is something we call a period. Period is categorized by the capital letter T, and it is measured in seconds. What the period is the amount of time it takes to complete one revolution. So now we do have our velocity formula, but it is transferred into circular terms. So it is 2 pi r divided by the period t. Sometimes it'll give you the frequency instead. And all the frequency is how many revolutions it will take in 1 second. So it is revolutions per second, whereas the period is seconds per revolution. So this means that the frequency formula is equal to the inverse of the period, and the period formula is equal to the inverse of the frequency. So there we have our velocity formula. It is constantly changing. So because it is constantly changing direction, we cannot use it as we normally would for the acceleration. So centripetal acceleration in this case is not velocity over time, but instead it is v squared over r. And this works out because we know that velocity is measured in meters per second. And when we square that, we get meters squared per second squared. And then if we divide it by meters, we end up with our acceleration of meters per second squared.